Today, we're diving into one of the biggest challenges in artificial intelligence, the quest to build an AI that can actually learn and remember over time, just like we do.
So if you've ever used something like ChatGPT or Claude, you've definitely felt this. You have this amazing in-depth conversation, you teach it exactly what you need, and then you come back the next day, and poof, it's all gone. The AI has zero long-term memory. Every single chat starts from a completely blank slate. It's pretty frustrating, right?
All right, so here's our game plan. We're going to start with what I'm calling the AI amnesia problem and the curse of forgetting. Then we'll look at the 5 levels of AI learning, explore 2 totally different ways people are trying to solve this, see how engineers are already faking it till they make it, and finally we'll peek into the future of AI memory.
So, the fundamental issue here is that today's big, powerful, large language models are completely static. They go through this incredibly massive, super expensive training process, but once that's done, that's it. Their knowledge is locked in. They are literally frozen in time.
What this means is their entire memory is limited to the single conversation you're having right now. This is what's known as the context window. As soon as that conversation ends, or you just talk for too long and push stuff out of the window, everything you discuss just vanishes. This is why they can't learn from experience, and why every single time you talk to them, it feels like you're meeting for the very first time.
And this inability to hold on to information, well, it's the biggest roadblock we have to creating an AI that can actually learn. It's a problem that researchers have been banging their heads against for years, and it's got a few very specific and kind of cool names.
Okay, so the ultimate goal, the dream, is something called continual learning. It's basically an AI's ability to soak up new information and learn new skills over time without just dumping everything it already knows. For us humans, this is second nature, right? If you learn how to play the guitar and then a few years later you decide to pick up the violin, you don't suddenly forget how to play the guitar.
But for a neural network, it's a totally different story. When you try to train an existing model on a new task, it often just completely overwrites and destroys the knowledge it learned from the old tasks. This is the main villain of our story, catastrophic forgetting. The new learning just wipes out the old, because all that knowledge is crammed into the same shared network of connections.
This all leads to this core dilemma, a real tug-of-war, called the Stability-Plasticity Trade-off. Stability is the model's ability to hold on to what it's learned. Plasticity is its ability to learn new things. You absolutely need both, but they're constantly fighting each other. You can think of it like a dial. If you crank the dial too far towards stability, the model is frozen solid and can't learn anything new. But if you crank it too far towards plasticity, it forgets everything the second it learns something new. Finding that sweet spot, that perfect balance, is the whole game.
Now, to really wrap our heads around this challenge, it helps to use a framework. We can actually break down this problem of continual learning into 5 pretty distinct levels of difficulty.
So you've got 5 levels. Level 1, session memory. That's basically what we have now with context windows. Level 2 is remembering stuff from one chat to the next. Level 3 is when it starts adapting to your specific tasks. Level 4 is true continual learning, where the model is updating in real time. And then there's level 5, the real prize.
And that's level 5. This is the holy grail, an AI that doesn't just remember facts, but actually learns and gets better from its own mistakes. Just imagine a coding assistant where you correct it once, just once, and it never makes that same mistake again. Over time, it would become perfectly tuned to you. That is the ultimate vision.
So, the big question is, how do we actually get there? Well, right now the AI community is pretty much split down the middle. There's this huge debate going on that's shaping 2 very different ideas about how to solve this.
On one side, you've got the skeptics. As researcher Dorsher Patel puts it, the fundamental architecture in models like GPT-4 is just not built for this. His argument is that you can't solve this by just making the models bigger or throwing more data at them. The problem is baked into their DNA. We need a completely new kind of AI architecture to pull this off.
And then on the other side, you have the pragmatists. AI researcher Nathan Lambert says that chasing some perfect new algorithm is basically a nerd snipe, a really interesting problem that's ultimately a distraction. He thinks we don't need some massive breakthrough. Instead, we can just engineer clever systems around the models we already have to get a result that feels exactly like learning.
So let's just boil this down. The skeptics see a deep algorithmic problem, and they think the only solution is a brand new type of model. The pragmatists, on the other hand, see a systems-level problem. They believe we can solve it just by building better memory and smarter tools around the AIs we've already got.
And you know what? That pragmatist approach is already out there, and it's getting some pretty impressive results. A fantastic example is a feature from the company Anthropic called Skills, which creates this powerful illusion of learning, all without ever touching the core AI model.
This system works using a really clever idea called progressive disclosure. So instead of just stuffing all the information into the AI's limited memory at once, the AI first just sees a simple list of skills it knows how to do. Only when your request matches one of those skills does the model load up the full, detailed instructions. It keeps things lean and fast, kind of like how we only recall specific memories when we actually need them.
Okay, but here's where it gets really smart. After your conversation is over, the system can go back, analyze any corrections you made, and automatically update the instructions for that skill. So the next time you ask for it, the AI remembers your feedback and doesn't make the same mistake twice. It's an incredibly powerful engineered solution that feels like the AI is actually learning.
And all this brings us to the future. Because solving this isn't just some academic puzzle, it has absolutely massive economic implications, and it's going to define where this entire industry heads next.
I mean, just think about this for a second. Retraining a single top-tier AI model like GPT-4 or Claude, we're talking millions upon millions of dollars. Every major update means spending a staggering amount of money and computer power just to create a new, static version of the model.
But if we can crack continual learning, we could just make small, cheap, incremental updates instead. This would completely flip the economics of AI on its head. That giant, upfront training cost would get replaced by smaller, ongoing costs for just running the model. This kind of change would totally democratize the field and let smaller companies actually compete with the big guys. So what's the path forward? Well, for the near future, it's pretty clear the pragmatist approach is winning. We're going to see more and more of these cleverly engineered systems that create the feeling of a learning AI, one that adapts to each of us. The skeptic's dream of a truly learning AI, one that thinks and learns like a human, well, that's a much harder nut to crack. That's likely still years, if not decades away.
At the end of the day, this whole quest for continual learning is about so much more than just building a smarter AI. The real goal, the true prize, is to create a genuine partner for our work and our lives. An AI that doesn't just answer questions, but one that can learn, adapt, and grow right alongside us.